Cool. Hey everyone. Very good morning and welcome to the meetup today. And yeah, I think since you guys are here at Meesho, we sort of changed the schedule a little and we thought we'll start off from the MQ only. So yeah, Ramiz here, Ramiz Mehran. I am the architect for data engineering platform, and what we are starting with here is MQ, something that we sort of built over the last 1 year and reaped the benefit immediately in the end of the term. So something exciting that I wanted to share with you all. So before we start, I'll just quickly get you to what is Meesho, where we are at, so that you get a sense of some scale. So yeah, basically we are the first horizontal e-commerce company to turn profitable. That was a significant milestone and achievement for us, and I think we can say for the Indian e-commerce as well. Then according to Data AI, we are #1 when it comes to shopping apps in India, and we have recorded 14.5 crore app downloads in just 2023. We facilitated more than 14 crore customers to do their shopping in 23, and we have 18 lakh sellers in our platform currently active. We are the world's fastest shopping app when it comes to crossing 500 million cumulative downloads, and we have 150 million plus annual transacting users on Meesho. And yes, we were the first to quickly onboard and enable non-GST sellers, and today we power 60,000 non-GST sellers, which is like the first in India. Thank you. Yeah, and 150 million annual transaction customers, where more than 70% of the sellers are coming from tier 2 cities. So unlike the other big names, it's not just tier 1. We are mainly concentrated towards tier 2 cities and beyond, and I think we are a popular name there today. Meesho's Android app is just 13.6 MB. That is one of the lightest in the whole e-commerce apps community of Play Store. And we get approximately 3 lakh requests per second at our gateway layer. Just some numbers to give the perspective. Gateway layer 3 lakh requests per second. Highest throughput service gets 4 lakh requests per second. We are on Kubernetes, so at the peak we get 2.3 million RPS per second. And in Kafka, we are handling 165 million records per minute ingress, that's around 42 GB. 260 million records per minute egress, that's around 90 GB. And 90 million requests per minute at peak. So this is what we are talking about, just at peak. So at Meesho, we are heavy users of messaging queues. We internally explored multiple of them and sort of have stabilized towards Kafka and Redis PubSub for now. It was the beauty of separating logic from load, and ability to smoothly scale forward is something that we just couldn't let go. So it sort of makes you feel like super powerful and makes you feel like you can handle 100x scale even if your system are just built for 10x. But one concern is that the moment any of the system grows in scale, grows in volume, even that little nitty-gritties start popping out. That why did I choose float, why didn't I choose string and not character? So how did we meet that specific requirements while scaling up? How did this tech, that is MQ, help us fast track one of the biggest challenges of moving from one cloud to a completely another cloud provider? We'll talk about it today. So just to get an understanding of the initial state, we were an active user of Kafka. We have been utilizing multiple stacks for it, but our first go-to was cloud managed Kafka. What worked for us was that it can easily be scaled up or down. It had detailed metrics and a good support team. What didn't work was we continuously were facing EBS throttling issues. There were certain broker degradation that will happen here and there. We had subpar client tuning, and horizontal scaling was a nightmare because that came with its own pros and cons and limitations of having to adjust the offsets from where you are at rather than where you should have been. Consumption patterns on how our clients were tuned to consume. Some were very, if your system fails away, I want everything right now. Then the traffic production patterns as well on how our producers were tuned, how they were working. We're missing certain tracking on the server end, and they were inefficient and unsupported scale downs at places. Then we evaluated other cloud vendors, and one that we rested on is Confluent Cloud for us, based on the multiple POCs that we did. Same, everything has its pros and cons. What worked for us was we got a lot of horizontal scaling capability, client level auditing, utilization based costing and not provision based costing. Inter-AZ replication is no longer an headache for us or a cost for us. A good discount based on our internal finance team discussions, and professional services support, and constantly improving auto balancing. I would like to concentrate on the last two part. Definitely the top 4 is something which comes with the infra or the provider, and it can vary. There are a lot more competitors outside, or if we choose to build everything in-house. What matters on the bottom 2 is what professional services helped us is sort of, we had certain problem statements and ways to think about, but what they helped us broaden is how to deep dive in more sections of such things. And constantly improving auto balancing, this is one of the key factors that we benefited from a lot in Confluent Cloud. Because rebalancing is one of the critical things that can decide what scale of your Kafka or any underlying MQ messaging platform can power what scale of your things. Even a very highly provisioned infrastructure but imbalanced in a way can lead you to have a much degraded performance. What didn't work for us? So there were slightly higher response latencies, considering that Confluent internally runs in Kubernetes instead of fixed infrastructure. They'll have certain sharing networks, etc. The tricky auto rebalancing part, same problem. What was a boon for us was also a curse. It took time for us to understand how it works. It took time for them as well to make it somewhat of a stable product. And then there are certain limitations everywhere. For example, per partition there is a max throughput limitation. You'll have per EBS certain max write limitation, and per pod you will have certain max network limitation. So now what I talked about just now is we went from one cloud platform, we went to another cloud platform. Okay, everything was solved for us. No. We did get support to solve a lot of things in a better manner, yes. But we had to get our hands dirty, we had to get down and look at that first problems that are causing the most loss or degradation for us. I think primary one is compression. The moment we enabled compression for our infrastructure, I think one thing most of the people who have been heavy users are for Kafka will realize, but the others who have just been introduced, when you're running these systems in production, there's a slight doubt that, okay, I'll enable some compression. Will my services throughput be impacted? Will there be something that will not work out of the box? With Kafka clients, your compression scenarios are handled 95% of the time, but you still need to be aware of those 5% conscious scenarios where it cannot. For example, if you have one client which is very old, running some 2-3-year-old library, it won't have a ZSTD support. But your LZ4 and Snappy sort of give you a good CPU to compression ratio. ZSTD might take a higher CPU, but the overall throughput capability will go up. The overall cost savings for you will go up. But that depends that, okay, if I am increasing my CPU by 10%, am I increasing my pod count by 100 or my pod count by 10, but I am saving Kafka clusters 50% provisioning capacity. So that's where consciousness needs to be in place. But again, compression is one of the biggest levers that can immediately drive optimizations and savings for you. Higher timeouts, yes, this is another critical thing that keeps raised every single time. That I want a timeout of 5 milliseconds, my API response time shouldn't be impacted. Your timeouts, whatever you configure, will also be the timeout that will impact your metadata refreshes. Now, when I talk about metadata refreshes, your metadata refreshes could at time, worst case, take more time because it has to fetch all of the configuration, everything in memory. You don't want that to impact your actual production, because if a metadata production fails, your client thinks that server is not at all available, I need to reinitialize the whole client, it will block all of the production requests. Another is skip 794, one of the key improvements in producer clients, where they have incorporated blacklisting support for slow brokers. So your client intelligently redirects the traffic from broker A to broker B, because your partitions could be across multiple brokers, without you actually having to intervene. Now, as you see, every single thing that we are discussing here comes with a lot of nitty-gritties, a lot of plus and minuses, and it has to be evaluated for every single use case. So this becomes quite tricky when you are actually building for a large scale, for multiple services, thousands of topics, and n number of Kafka clusters. So that's why MQ was the base framework which came to our mind, that we want an abstraction that helps us bring those optimizations, those constraints, either out of the box, wherever it is very large, impacting and very straightforward, or at least in a framework which lets developers understand that, okay, I'm setting it to 20, what can happen, or I'm setting it to 50, what can happen. Second is that the most tricky part on owning Kafka and doing migrations is understanding the dependencies and taking care of that with downtime or without downtime. The moment I talk about without downtime, all of the developers here will realize that that itself means 3 to 4 deployments of your services, tracking all of the metrics, restarting, offset correction, etc., etc. We wanted that to be zero. We don't want any of our developers to deploy any services. Migration should happen by just them sitting, looking at a Grafana, and things should work fine. How did we power that? What did we do to make it a complete solution? And I think that's what was the drive behind MQ. So let's start. What is MQ? MQ is a queuing platform for Meesho. It is also, you can also call it a queuing abstraction for Meesho. Whatever the implementation of utilizing that underlying infra is, that is also standardized within the library for the best possible versions and for the best possible approaches. We have started it to build for now using Kafka protocol only, but our plan is to further add supports for whatever new protocols or whatever new systems are available. Now, what is the role? The role is that what we have realized is, as the messaging queues have scaled up, there is a lot more capability and possibility that they have brought in, but that also comes with a lot of conscious calls and tunings that they provide now. So in terms of complexity, you could say that 90% of the time you just install something, register it, make it and it works, but that last 10% can become a nightmare, wherein something will just not work according to what you had expected it to work. Second, an important factor for us has always been cost, and which I think is an important factor for every single startup and companies also nowadays. So how do we justify the ROI for whatever we are doing? How do we justify that everything is happening at scale but at economy? It's very easy to say that I can launch a 4x size cluster and everything just works for me. But how can I say that, no, I'll run a 0.9x cluster and I'm confident that my BAUs will be sufficiently fine. So MQ enabled us usage of these queues at high scale without actually worrying about all of these nitty-gritties, because proactive approach is much better than reactive. Rather than something failing and you coming to fix it, we sort of build a platform where we suggest that from day one to users to utilize that. Objective of Meesho, MQ, yes, we wanted the ease of use and standard configurations in place. We wanted to decouple the messaging infrastructure from the underlying technology. We don't want that tomorrow we decide a new platform or an in-house cluster deployment. We don't want to go to every single client there is and again manually do the deployments or corrections. And then finally, the standardization of configurations, that if you're using Linger MS0, are you an async flow or a sync flow? If you are using buffer memory of 10 KB, what did you think? Why did you use a buffer memory of 10 KB? What is the batch size of 10 KB? What does it prove for you? So this, I think I've set the context, so I'll take you through on what is a generalized architecture of the MQ currently. So I think two critical things here. One was that fast to production was a key metric for us, and we needed a lot of other savings and a lot of other activities were dependent on it. So this is like the V1 which helped us achieve that while giving us the core needs which we wanted to fulfill. So if you can see here, very easily our MQ is divided into two components. One is the MQ client, another is a config server. MQ clients are built to be inside all of the applications, be it a Spark app, Flink app, Spring application, or a Golang application. We have a certain spec that we are working on, which sort of defines the whole MQ client as a defined standard. This MQ client can enable us to consume from anywhere. It is MSK, Confluent, Redis PubSub, Red Panda, or anything that comes forward. The main idea here is behind, first, what is an application? An application is one unit of deployment so that you can control what happens on a producer level, on a consumer level, on a migration level for one deployment. Second, what is a messaging queue? This is very important. A messaging queue for us, we are not talking about a topic in Kafka. We are not talking about a subject in Redis PubSub. A messaging queue for us is one unit of data flow. The moment you think about this, not like a topic, but rather a unit of data flow, basically a data pipeline, you get to play around a lot more and you get to move away from the restrictions which you might feel when you are thinking about only one topic. Why? When I talk about data flow, what it defines is that my data pipeline will have n number of producers, n number of consumers. They have a certain defined specification that this is the guarantee that it should work in so protocol, it should work with so certain latency, and that's what defines my data pipeline flow. Now, powering this, if you're using Kafka, can be a single topic, can be multiple topics. I don't think as long as the production and consumption are happening and your business logic is justifying certain SLAs, it works fine. So what I'm saying is that the power here is that your messaging queue could be one topic where X and Y producer is writing, another topic where A and B producer is writing, and a set of two consumers which is consuming from both, making sure that your offsets is maintained. And yeah, so definitely another concept will be the publishers, which is a set of producers, consumers. MQ types, we wanted to, instead of asking users that tell us you want Kafka, tell us you want Redis PubSub, tell us you want Red Panda, we are saying that we'll define it at certain, like at most one, we want a reflow capacity, etc. So that then intelligently behind the system we can decide what works best for the use case. Another is annotation support. This was a bit key which we evolved over time, is because even if there's a new rewrite that we are doing, there are certain protocols that a developer is used to, and rewriting all of that or rewiring them to use a completely new thing is quite tricky. So how did we reduce that to a minimum so that whatever a user is doing, a one-line change should be enough to move them from one protocol to another? And then finally, rate limiting. Rate limiting is something we wanted within the infra as well as from the supporting infra available, so that we don't want one client impacting others. Yeah, so this is, I think, we'll go a bit on the inner workings. So what I displayed before, it is just a little more evolved version of that. So what you see here is there is two different applications, and we have changed the @Kafka listener property to @MQ listener property, and that helps the client to make their consumers as well as producers work out of the box, because currently there is only two line changes. One is @MQ listener, one is MQ service.send. Previously they were doing Kafka template.send. Internally what we have done is we have tried to build in more control, as in whether I want to directly create connections on the underlying infrastructure or I want to bypass that through another proxy. Because the moment you add a lot more clients and a lot less throughput, because I think that will be a common pain point in a lot of places where your Kafka servers are, or any server is pretty high, because more than the capacity, it's creating a lot more connections. Even today we have databases scaled up primarily because of connections, and then secondary a lot will be on the overall volume and the scale. So this is where we get to control that the moment you bring a proxy in between my overall connections, which could be 5 services having 500 pods versus a single service only having 100 pods, because my scale is less. I don't need 50,000 connections, I can work with just 5,000 connections. So when it is the nitty-gritty that we are talking about, not just your clients, your servers limitations will also come into picture. And that's where this proxy support, or consciously taking the call that I have a scale where I'm running at very high throughput and very high request count. I don't want a proxy because just for that one case, which it could become the 90% of my proxy's traffic, I am fine if I bypass that, but that sort of reduces my latency in the overall end-to-end architecture. So what we wanted to do here is we wanted to have support for us to take a call whether something has to go through proxy or not, but everything goes through clients. So everything still works out of the box, but still we get the control whether we want to do it via direct connection with the underlying infrastructure or via proxy. What you see as async queue and RxJava retrofit there, these are just libraries that we wanted to utilize, that even if we were using imperative code flows, we didn't want to be stuck with the limitations of threads when it comes down to concurrencies. So that's why we also inspired from how the Kafka library itself works internally, where you get multiple queues, multiple batches, and sort of each one having their own individual connections, so that any one block that fails, everything else continues to work. So we wanted to add that kind of a support here. So that's how we sort of clusters, and same goes for consumers. So once you have defined @MQ listener anywhere, the consumer continues to work. The smart thing is that your consumer could be just a object instance created from a Kafka container factory, or it could be just an endpoint which is receiving a request from another proxy consumer, which consumes it and pushes it down. Again, that is a call that you can take based on your needs, based on the ordering requirements, based on the throughput capacities. But what it helps us is that the moment I say that I am only initializing Kafka Container Factory for now for the consumer, 99% of the things are supported out of the box. So what I'm just trying to say here is that we took certain conscious calls. There is definitely more that we are working on. There is definitely more evolution that we'll be working on here, but there is that certain balance between time to production as well as overall returns that we are talking about. So that's where we smartly try to balance that out. So today, with confidence, we can say that for producer and consumer use cases, whatever Kafka works out of the box, everything is supported. Now, yes, over top of that, we are further adding more support to make it more linear, make it more gradual. This is how the internal client works. So, yeah. So basically, you just Java with gRPC and etc. and whatever benefits it builds us. Then you have the final MQ server, which will make less number of connections rather than more connections downstream to Kafka. That also enables better batching. So better batching means more compression and etc. etc. Then the option is for dedicated producers where, like I said, very high throughput, very low latency requirements. You just select the mode from proxy to dedicated and you make a direct connection, and whatever was supported before is still supported now and everything just works. Same place, we also decide for the consumer type. What user is doing is they have only defined the MQ listener with certain consumption. Whatever their logic was, no code changes are needed than one line. But based on is it a dedicated consumer, it will immediately create a container factory, or consumers are initialized and things work out of the box. If it is not that, but rather the proxy flow that we have talked about, so we'll run a separate consumer which consumes, does whatever binary serializations, that is the compression has to do, and calls the endpoint. The endpoint internally will decide which function to trigger based on the responses, whether to commit or not, whether to pass the offset commit, to retry, to put to dead letter queue, and all of that abstractions. So yeah, so what did we benefit from this? When I say simplified migration process, we were able to take 250 services and I think thousands of queues to GCP from AWS within a month to 45 days. And that was a month to 45 days because we were doing it at that scale for the first time. I can probably say the next time we do it, we can maybe target 15 days or something if needed. So that was one of the key wins for us because we had the complete chart, we didn't. And second, what that did was I can immediately query the central configuration and realize who is using ZSTD and who is not, who is using lingerms 0 or who is not, who is using min fetch bytes of 0 or 20. These are very critical configurations. These are the configurations that can help you reduce your consumer pod count from 10 down to just 2 while maintaining same latencies, while maintaining same consumption capacities, and having no impact on your logic while saving a lot as well. And that's where I think the real world saving comes into picture. So what we have seen currently is we have saved around $40K a month ever since moving from the managed to Confluent. And that includes the GCP migration and centralization and the config correction. What it has also opened for us is the lever to bring in more savings without, again, investing time in understanding every single flow in depth. So that is a lot more important than this 40K because that understanding there is a direction and a lever to more optimizations there is I think one of the key time which a developer spends time in. What am I supposed to do which will give me some ROI? Third, yes, there's a streamlined developer onboarding. I would not say it's completely solved for us currently. We are still working on because we are understanding that, okay, this developer might need this additional info as well or that is missing. So, and efficient Kafka configuration, a UI-based configuration update. So I'll show you after this how that is. And an efficient cross-cloud migration without downtime or deployments. So I think that's what I mentioned, that why we did it in a small time, because like I said in the beginning that I hope I have time. So like I said in the beginning, I can say that this messaging queue is just a data pipeline. So what I can do now is I have Kafka A and a Kafka B. What I do is I create another topic, same name, same configuration, everything in Kafka B. And I start duplicate consumers here, consuming from Kafka B. The moment those consumers have started, just to make sure because you are in production, we have a filter in place which like tests that, okay, test payload is received, it's acknowledged, everything is working fine. And then we just move the producer to point to Kafka B. The moment your Kafka A offset commits have cleared, or you can wait for 24 hours because it's production to get an approval, you just stop the first consumer. The step that I talked about is pretty straightforward, and I think that's what everyone today does whenever they are migrating anything in production for Kafka. What we did was within the library, we made it so that this happens in a very simple config refresh within 15 minutes. So if I am saying right now that I am migrating 10 topics dependent on 20 different clients, I can do that within 1 hour. I'm talking about P99 because I trigger step 1, and this is another intelligent, I think, efficient thing that we did was we sort of build that as support in UI. So what, it's funny, but what our developers who were doing the migration, what they had in front of them was, it was just step 1, step 2, step 3, and step 4. So they'll go to step 1, they'll mention Kafka B, step 1 is done, secondary consumers have started, they'll click on step 2, test validation is sent, acknowledge has arrived, whatever consumer has cleared, it has been ticked that, okay, I am ready for migration. They'll click on step 3, producer will shift to the new Kafka. Before that happened, in step 2, we have validated the producer configurations, we have validated the consumer configurations, and we have validated whether the system is ready or not. And step 4, after producers have migrated, we will just stop the first consumer. So this enabled us to have zero deployment, zero downtime migration, while asking the service owner developers to just sit behind a Grafana and look at if things are working fine, and then do this efficiently. So I think this, I would say, is one of the most important features of MQ, which is well tested in production today. So this was the team behind it. We had a good team, and everyone did their own individual Flink, Spark, and overall architecture kind of discussions. So I think, yeah, that's it from my end on what I had to speak about. Open to Q&A and open to questions if you guys want to ask anything on the nitty-gritties. Yeah.
So you mentioned about so you mentioned that you will send all the messages to a proxy endpoint, and then proxy will connect to the Kafka broker to send messages. So doesn't it act as a single point of failure?
Yeah, exactly. So that's why the proxy evolution is something that we have taken as a secondary step. We started off with direct connection, the dedicated one that I talked about. In proxy, what we are evaluating is how can we sort of declusterize or decentralize that on maybe company level, but rather a smaller cluster on BU levels, etc. And only work on the specific situations where there is a lot of ROI. For example, let's say we have 10 BUs in the company. 8 of my BUs have very less number of services, very less number of connection overhead, and cluster utilization of, let's say, 60%. But 2 of the BUs, which is like a central BU where everything connects to, where it's like 500 clients are there, but my overall cluster utilization is only 5%. So that is a place where 95% of my benefit is there. So that's where we want to intelligently shift between a dedicated and a proxy flow behind the scenes, and then only work on one where there is a considerable ROI. Secondly, because I say that my client today has both dedicated and proxy support, the moment there is any such failure on a proxy, the fallback to dedicated still continues to work. The only lacuna there is that I have to scale my Kafka in time so that is ready for that influx of connections. But on the client side, that control for 2 helps me intelligently divide on the saving versus, let's say, a fallback flow so that things continue to work.
Sorry, fallback of resin. You have multiple instances of proxy, or what exactly was the fallback?
Yeah, so one is, yes, multiple instances, because the proxy itself is sort of a distributed infrastructure. Even if that fails, you can have that discussion, that fallback happen here. So whatever is the configuration, everything remains the same. I have the MQ, I have the configuration, I have the destination. I am choosing to go the proxy route because it seems to be efficient, but in case things are down, I can immediately just let this work as a fallback for the time being. Yeah, is anything, I think if not MQ, we can discuss anything if you want about Kafka as well, or in general about streams as well. If you have any questions, we can.
Kafka, and where do you use Redis PubSub?
So I think one of the key points for a developer there to Redis PubSub, like PubSubs usually are, even if you go for the Google PubSub library. Unlike Kafka, they don't have TTL separate to subscription. You say that I still want to keep my data for 7 days. PubSub says that if X message is there and there are N subscriber, if all of N subscriber have consumed, I'll delete the message. But what that brings in is a lot more throughput on a lot less infrastructure and a lot less money. So I think that is a conscious call, which, and based off the design and based on what is your constraints, you can take. And that's why, and I think that's why I said that we'll streamline it by just saying whether you want at most once or whether you want reflow support, and that sort of takes care of inside the infrastructure.
Thanks.
Yeah, thank you.
So you mentioned that you have a managed Kafka and you migrated to Confluent, right? That is also managed, right? So what really brought the savings? Because they are also internally using AWS.
Yeah, I would say that's why I pointed out that we can discuss about. One is that, okay, I'm working and I'm deploying an infrastructure at X and X and everything is working out of the box. Second is I am deploying the infrastructure at X and X, but my utilization is only 20%. My secondary infra gives me more power, more metrics, more capabilities to reduce that down to 0.5x. One problem with any distributed system is, you need to have metrics to be able to control and realize what is it that you want to fix. Because it's very difficult for anyone today to say that, okay, this Kafka will work at 10 Mbps, this one will work at 100 Mbps. The data type, the kind of load, what is the overall connection count, what is your trend, because you never provision, at least fixed systems like Kafka for BAU, you provision them for peak. So if you're provisioning it for peak, you have to make sure, if you have to save costs, that either you have very frequent peaks or your peak is somewhat closer to that, to your BAU, so that your overall utilization of the infrastructure is high. What this enabled us was bring more visibility into the system. And second, that's why I mentioned the auto rebalancing part. So that is something which for now is only available in managed, but it is being researched and worked on in open source as well, wherein you just add 3 nodes and all of your partitions rebalance distribute across with 0 downtime. So that is something that we saw as a benefit when we moved from X platform to Y, that Y being Confluent Cloud.
All right. So then a follow-up question would be, you can obviously, you have some great engineers, you can obviously do it in-house.
Yes.
So was it like a trade-off between the time you could spend on engineers versus what you're getting?
So I think what I would say is there is, even if you get 20 engineers today to start working on a project from scratch, versus the lead time which a 10-year industry standard people who have built Kafka themselves have learned and built from, it's not 1:1. What you will need definitely is a considerable time, but it is not something which you cannot do. So one of the big reasons, one of the big levers for MQ or any such platformization activities happening within Meesho, or I think across any company, is that the moment now we can put that bandwidth or pick that system up, it's no longer a constraint. I know I don't need to get my developers aligned. I can behind the scene move 5-10% of the traffic, evaluate things and move back. So that is definitely the end goal, and these are the means that we gradually go there.
Okay, thanks a lot.
Thank you. Or Kafka discussions, I'm always up. So thank you, and you have been a great audience.